Hi, today we're going to talk about the ActivPower architecture of this series of D-Bolt ATMs. The new ActivPower architecture consists mainly of hubs, control cards, and power supplies that all communicate with each other outside of the terminal's PC. It's done completely independent. The first control card I'd like to talk about is the upper control card. This card is a USB hub and is where all the power begins inside the terminal because that's where the power switch is. The first switch we'll talk about is the white rocker switch, and it's a maintenance switch that works just like the switch in our previous family, Optiva, in that it triggers maintenance mode. Works just the same, except it's now located in a new position that will always look like this, no matter the ATM that's being worked on. I'm going to skip the blue switch for a second and go straight to the black one. The black switch can be thought of as the master power switch for the terminal, in that if it is thrown, it will safely shut down the machine and turn off all modules, but it will act as if AC power is removed and that any alarms or batteries inside the terminal will run on those batteries as if AC is gone. That's what this LED indicator is meant to show you, is that whether the machine's on or not, that's not what it's indicating. It indicates whether AC power is present. That could be useful for a service guy or troubleshooter trying to figure out why his machine's not on. Backing up to the blue switch, we call it the idle mode switch, and it's also a power switch in that it will safely shut down the machine and remove power from all modules, but it will leave the hubs and control cards with power so that they can continue to communicate, as well as keep the battery charger inside the safe on and provide power to the alarms. This upper control card, as I mentioned before, also contains a USB hub that will be reserved for our service team. There will always be ports available for them to plug in whatever equipment they need to bring to that terminal. A second card that's present in all of this series of D-Bolt ATMs, part of ActivPower, is called the Fascia Control Hub. It consists primarily of three different types of connections, the first of which is a standard USB port, which is similar to our Optiva line. It uses 5 volts for power and simple USB communication. We have several devices that utilize that type of connection. A new connector that was introduced for this series of ATM is called a powered USB connector. We use the term low current, and what's different about it is that it combines USB communication and 24-volt power. For that 24-volt device, we call it low current because it will provide power for a device needing up to 5 amps. Similarly, the third type of connection, it's physically 2 connectors, but the port itself is paired, so it can be thought of as one port, and we call it a high current port. Similarly, it combines 24-volt power and USB communication, except they are paired together logically, and I'll explain what that means in a second. But it will provide 24 volts for a device needing more than 5 amps, up to 15 continuous. All of these ports are equipped with LED indicators. The LED indicators will tell you if a device has enumerated on the USB bus with a green LED, and if it's a 24-volt channel, a blue LED will be present if that port is on. Again, these are tools we implemented to try to help our service teams and manufacturing folks troubleshoot issues. With these ports, they can all individually be turned off instead of the entire terminal, which will help an installer or service guy change out modules, troubleshoot issues, all of which will save time instead of waiting for the machine to shut down. That should help increase uptime and reduce the amount of time spent at a machine. Depending on the terminal type in that series, there could be 2 additional hubs, conveniently named after their location in the machine, depending on the number of modules needed or configuration. There could be a hub in the upper cabinet somewhere. We just call it the upper chassis hub. In this 7700 terminal, it's mounted right here on the center wall. And similarly, there's another hub down in the safe, just called the safe hub, for modules that connect down there. In addition to these hubs and control cards, there's the 2 power supplies present in the machines, an AC to DC supply and a DC to DC supply. Both these hubs communicate with each other, both these power supplies communicate with each other outside of the PC as well, and that's how all of the power architecture is constructed. The DC to DC is there to provide charging for batteries, and with that we also get a terminal level battery backup instead of just the processor that we had in Optiva. With these new features, we hope to reduce the amount of time spent at a machine on a service call, as well as increase the machine uptime.